we are going to talk function notation. So last time we were together, we talked about relations, which pair inputs with outputs, and functions, which are a special kind of relation. And today we're going to talk all things function notation. So we're talking about like how we write these things by hand, right? How we notate functions. We are not creative in math when we name things. We tell it like it is, which is what I always tell my students. So here we go, function notation. All right, we look at this and we say, this is important, down here, f of x is how we say this. So f, every part of this has a certain job. So f here, this is the name of the function. So my kiddos have two names so that I can keep them apart, right? They know I'm calling for them, and I mix them up, get them confused with the dog even, but it's handy because then my husband and I can differentiate who it is we're talking about. So just like your parents named you, here functions are all going to have a name so that we can tell which ones we're talking about. If I say, oh, f is, I don't know, increasing in this interval, you'd be like, oh, yeah, I know what function you're talking about. But if I say g is doing something else, then we could tell them apart. This guy here, x, inside those parentheses, this is the input. That's what's getting plugged into our function. And then this expression on the right-hand side, this 2x plus 1, that's what's known as the rule. So it tells us, hey, I'm inputting x into my function. I'm then going to double it, and then I'm going to add 1. And that's what happens to every single input. That's how we pair it with its output. All right. But something really important to talk about is even though this f, right, is right up next to this set of parentheses, and I've been talking about how parentheses mean multiplication. In this instance, it does not, right? So this doesn't mean that I have f being multiplied by x, okay? But f of x, right, it is telling us the value of our function f at x, right? It is like y, right? So in the past, we would have written, say, y is equal to 2x plus 1. With function notation, we are going to have f of x showing us our output. And why that's so much nicer than just putting y, we'll be able to demonstrate in a second here when we start evaluating expressions. In example 1, you'll be able to see that it not only tells me the function, it's telling me what I'm inputting at the same time, which is just fantastic. All right, so example 1, I have a function here called f. So I want you to evaluate f of x is equal to 2x minus 7 at different points here. So here I said when x is 4, and here when x is negative 2. So what I'm going to do is everywhere there's an x, I'm going to plug in that 4, just like we did before when we were evaluating expressions at the beginning of the year. And then I'll simplify. So I had my function f of x is equal to 2x minus 7. I'm just going to rewrite this, right? So see how everywhere I'm drawing an x here, right? 2x minus 7. That's going to get replaced. So instead, this is going to look like f of 4 is equal to 2 times 4 minus 7. So notice how I did put parentheses there when I inserted the 4 in place of x, right, when I made that substitution, right, because the 2 and the x were being multiplied, right? So if you want to show what we did here, right, we did a substitution, right? So we substitute 4 for x. And now I'm just gonna evaluate. So what that means, right, is I'm looking at order of operations and kind of cleaning this up. So, well, I guess a better word to put there would be to simplify, right? But I'm being really picky about my vocabulary. So this is gonna look like 8 minus 7. I'll do that subtraction and I'll get out 1. All right, so similarly over here, where there used to be an x, I'm going to put negative 2. So f of negative 2. See, that's so nice because it tells me, oh, I took my function f and I'm plugging in negative 2. All right, so same kind of thing. I'm making my substitution. I'm just going to put subs negative 2 for x. And then I'm going to simplify. So this will be negative 4 minus 7. That's going to be negative 11. All right, next we're going to see what this looks like graphically. So here I've got my function. It's already been graphed here at the right. And I want to know, remember, right, f of x is the same as saying y, right? That's the outputs are there. This is my function f of x here. So here, this is my f of x right here. That function is the function f, right? So this is still the, yeah, that's what I meant. Okay, there we go, fixed it. So, anywho. So, hopefully you read, right? We're going to consider this graph here. We're looking at what is the value of f of 2. So, f of 2, right? I'm thinking, where is x2? Well, x is 2 right here. And so here is where my graph kind of crosses over, right? So this is asking me, what is the y value of my function when x is equal to 2? And so we would say, right here, that's the point 2, negative 1. So we would say f of 2 is negative 1. Oh, the Scribble Race Chronicles. All right, so what's the value of x then when f of x is equal to 3? So here, this is asking me a little bit different question. So here, this is saying f of x is equal to 3. This means that my y is equal to 3. What is x? So we need to think about where y is equal to 3. And that happens right here. That is the point 0, 3, right? So we'll say that happens when x is equal to 0. All right, next. Example 3 here. Concerning each of x is 1/3 x plus 2. Let's go ahead. First, we're going to evaluate for negative 3. This is often how I show these problems, like on a worksheet or when I'm having my students practice, because I can ask questions about inputs versus outputs using the same function where you've got So I have one function and then 3 different questions here. All right, so I'm going to evaluate for x is -3. So again, that means I'm plugging -3 in right here for x into this function h. So I'm going to have h -3 is equal to 1/3 -3 plus 2. All right, well now I'm going to simplify. So 1/3 times -3 will be -1 plus 2, or 1. So this tells me that when I plug in -3 into my function, I'm going to get out 1. Now, I can similarly, I can ask nearly the same question using this notation here. So when I say find h of 0, it's also like saying let's evaluate for when x is equal to 0. So I guess I do lazy color coding. So I like to write all of my one color in and then do the rest. So h of 0 is equal to 1/3 times 0 plus 2. So those will cancel, right? We'll end up with 0 plus 2. Or, oh man, what is that? 2. This should be a 2 once I'm done battling with scribbleries. All right. And last but not least, find the value of x. So here I'm looking for the output for which h of x is -4. So, man, scribbleries and I are just really having a hard time today. So I'm looking for x, and I've given you this y value. So what that means is I'm going to have -4 here equal to my function h. So 1/3 x plus 2. And now we're going to solve for x like we have been doing all last chapter. All right, so you know what? That just looks like it's written really poorly. So I'm going to rewrite that whole thing. Bear with me. All right, so it was -4 is equal to 1/3 x plus 2. So we're going to start by subtracting 2 from both sides. Have -6 is equal to 1/3 x. And then we'll multiply both sides by 3 to get x alone. And we'll have -18 is equal to